All right, let's talk about one of the toughest, most common questions in any technical interview. We're going to build, step by step, the absolute perfect answer. So the next time you walk into that room, you'll have all the confidence you need. Let's dive in.
And there it is, the big one. You know, this single question is designed to test pretty much everything. Your knowledge of architecture, best practices, you name it. It can feel like a lot, but honestly, it doesn't have to be overwhelming. We're going to build a really clear, structured answer together, starting right now.
Look at this. This right here is our North Star. This is the goal. It's the strong, confident answer we're building towards. Now, over the next few minutes, we're going to break down every single part of this so you don't just know what to say, but more importantly, you'll understand why you're saying it.
Okay, first things first. Before we can even start talking about making an API fast or secure, we need a solid foundation. You could think of this as the blueprint. Getting these core principles right isn't just a good idea, it's absolutely essential. So here it is, the first and maybe the most important rule of all. Your API endpoints should be about things, not actions. They should be nouns. We're talking about resources like users or products or orders. We don't put the action in the URL itself. This one simple rule makes an API so much more intuitive and predictable. And you can see the difference so clearly here. Look on the left, /users/orders. Simple, clean. It's obvious we're talking about resources. The stuff on the right, /getUser/createOrder, it's just clunky. It gets confusing fast. So always stick with the nouns, because the action, well, that's handled by something else.
And that something else is the HTTP method. This is how you tell the API what you want to do to that resource. So if you want to read data, you use get. You want to create a new order, you use post. This separation of the what, the noun in the URL, from the how, the verb in the HTTP method, that is the very heart and soul of good RESTful design.
Of course, communication has to go both ways. When you make a request, the API needs to talk back and tell you how it went. That's what status codes are for. Think of them as a universal language. 200s basically mean everything's good, 400s mean, uh-oh, you did something wrong, and 500s mean, oops, something broke on my end. Using these correctly is just critical for a robust API. Okay, this next concept is huge. Statelessness. It's like having a conversation with someone who has no short-term memory. Every single request you send has to contain all the information the server needs to understand it, like who you are. The server forgets everything the moment the request is over. Now that might sound inefficient, but it's actually a superpower. It means any server can handle any request, which makes your whole system way easier to scale and a lot more reliable.
All right, let's wrap up our blueprint with two final essential details. First, version your API. Put it right in the URL, like /v1. Why? Because someday you're going to make a breaking change for /v2, and you don't want to destroy every app that's still using the original. Second, always return your data in a consistent format. It makes life so much easier for the developers who have to use your API.
Okay, our blueprint is looking solid. Now let's talk about the engine. Because let's be real, a beautifully designed API that takes 10 seconds to load is a useless API. We have to build for speed from the very beginning. And here's our performance toolkit. Each of these strategies is a great way to build a snappy, responsive API. Now, we could spend an hour on each one, but for today, we're going to focus on the two that will give you the absolute biggest bang for your buck. Caching is your #1 weapon for performance. It's simple. If you have data that doesn't change every single second, you should be caching it. By telling a browser or a server to just hang on to a response for, say, 60 seconds, you can stop tons of duplicate requests from ever even hitting your server in the first place. And here is the second golden rule of performance. Don't use a fire hose when a teacup will do. If a client asks for a list of all your users, and you have millions of them, you will crash everything. So instead, you use pagination, just like you see in this URL. You break that massive list into small, manageable pages. It's a lifesaver. So, we have the blueprint. We have a powerful engine. Now, we need to build the fortress around it. Security is never an afterthought. It has to be a fundamental piece of the design process. Let's take a look at how to protect our API.
The key to security is layers. There's no single silver bullet. It all starts with HTTPS, encrypting every bit of traffic. Then you've got authentication, which is about proving who you are, and authorization, which is checking what you're allowed to do. And as you can see, the checklist goes on, from validating inputs to rate-limiting requests.
Out of everything on that list, one of the most critical is input validation. The golden rule is simple. Never, ever trust data that comes from a client. Always check it on the server. I mean, even a tiny piece of C# code like this, just making sure a name isn't a million characters long, is your frontline defense against all sorts of common attacks.
Okay, so we have our 3 pillars: a solid design blueprint, a high-performance engine, and a secure fortress. Now, let's put it all together and craft that killer interview answer we talked about at the very beginning.
Here's the pro tip that's going to set you apart. Don't just list a bunch of terms. Tell a story. Put it in context. Say something like, well, if I were designing an API for a banking app, security would be everything. I'd use role-based authorization to make sure users can only access their own accounts. For performance, I'd cache transaction history using something like Redis. See? That shows you don't just know the theory, you actually know how to apply it.
And there you have it. If you get nervous and you need to boil it all down to one powerful sentence, this is it. It hits every single key principle we talked about today. It's clean, it's comprehensive, and it shows that you truly understand modern API design.
Of course, when you give a great answer, it often leads to a follow-up question. So you should probably be ready for this one. So how is REST different from SOAP? But you know what? With the foundation we've built today, you're in a fantastic position to not just answer that, but to lead a really great technical conversation. Thanks for joining me for this explainer.